Alright, so if we typed in y equals tangent theta, or you can look at your unit circle, you're going to find that tangent of theta is, since it's opposite over adjacent, 0 over negative 1, which is 0. Negative 135 would be positive 1. Negative 90 would be undefined. Negative 45 is negative 1. At 0 degrees, it's 0. At 45, it's positive 1. 90, it's going to be undefined again. 135 is negative 1, and 180 is 0. Taking what we know about reciprocals, cotangent would therefore be, if tangent is 0, then 1 over 0 becomes undefined. And this is going to stay 1. This is now going to be 0, because flipping a 0 on the bottom. Negative 1, undefined, 1, 0, negative 1, and undefined. Alright, so if you take these points, make sure you have these points down, and we plot them over here. So at negative 180, it was at 0. Negative 135, it was at positive 1. Negative 90 is undefined. We graph undefined as a vertical asymptote, because undefined means you can't graph it. And a vertical asymptote is something that your graph approaches but never actually hits. All right, at negative 45, it's negative 1, 0, 0, 45, 1. We have another undefined, and negative 1 and 0. So how we're going to connect this, I'm going to start in the middle, is we're going to connect it with a curved line. So this would be kind of like the start of one of the curved lines, and this would be the end of the curved line. Okay. Alright, if we do that same thing with cotangent, so plot these points, we would get undefined at negative 180, undefined at 0. It's usually easier to start with the undefined, and positive 180. And then I also had negative 135 as negative 1. I'm sorry, that's not right. I should look up there. Negative 135 is positive 1. Negative 90 is 0. Negative 45 is negative 1. So now we can see it's a very similar shape, but now we're going down instead. And so that's our shape. So how we're going to graph this is actually going to be pretty different, but keep this shape in mind. This is how we're going to connect the shapes. But in order to graph this, I need to talk a little bit about the theory of tangent and cotangent. So if we think about tangent of theta, tangent of an angle is equal to opposite over adjacent. Well, opposite over adjacent is O over H, or over A. If I take this opposite and I divide by H, so if I divide the top and the bottom by H, I'm allowed to do that, because as long as I do it on both top and bottom, I've done a valid move. So now I get opposite over hypotenuse over adjacent over hypotenuse. And that's going to be beneficial to me, because opposite over hypotenuse is actually sine of theta. Sine theta is over H. And cosine theta is adjacent over hypotenuse. So what we just figured out is that tangent of theta is equal to the ratio sine theta over cosine theta. And the reason why that's beneficial for us is because when you have a denominator, denominators create undefined terms, because when the denominator is 0, then you're having something over 0 which is undefined. So having a denominator is actually helpful because it tells us a lot about the graph. We know from what I said up here, if I have something that's undefined, I'm going to graph these undefined lines, and then in between is that shape. Okay, and so for that same thing, we can say that cotangent of theta is this guy's reciprocal, so that'll be cosine over sine theta. All right, so let's go on. So what similarities do we notice? Well, the similarity was that they're both kind of that shape, but tangent theta, we call this increasing when it goes from bottom to top. So tangent of theta is increasing and cotangent of theta is decreasing. But they have that same shape. What is the period? If you go back, you would see that one of those cycles, this is a cycle, would take from here to here 180 degrees, which is exactly half of the typical sine or cosine. Sine and cosine were typically 360 for the parent function. One last thing. If I talk about, once again, tangent theta, I graph tangent theta, this is tangent theta. Now, if I reflect tangent theta, if I do negative tangent theta, then when you reflect it, it's actually going to have this shape. So something that you should notice about a negative tangent of theta is that it's actually going to be equal to cotangent of theta, because the only difference between the two was the shape of it, increasing versus decreasing. Okay, so we talked about our process, but our process is going to be to graph the denominator to find undefined. And those will be our vertical asymptotes. Okay, so let's do an easy example to start with. So since this is tangent of theta, well, I know tan of theta is sine over cosine. So what I'm actually going to graph here is I'm going to graph cosine. I'm going to pretend like all of this graph, all of this information is for cosine. And then at the very, very end, I'm going to adjust it because it's actually tangent. But cosine is going to tell us how to graph it. So this is an easy example because if you notice, there's no vertical shift, there's no horizontal shift, there's also no amplitude, nor is it reflected. So my vertical shift is 0, my horizontal shift is 0. I do not reflect, therefore cosine starts up, and I have an amplitude of 1. Now the only thing that is changing is the period. So I'm going to take 360 and I'm going to divide it by 1/4. And I believe you get 1440. If you divide that by 4, then you go back to 360. Okay, so if we graph this, again, you're just graphing as if this were cosine. So if we graph this, start at the 0, 1, 2, 3, 4. 1, 2, 3, 4. So this is 360, 720. What is that? 1080, 1440. Okay, keep going is 1800, 2160, 2520, and 2880. My amplitude is 1, so from the 0 I'll go up 1 and down 1. The sinusoidal axis is on the 0 line. Okay, so cosine starts at the top. Let me do this in a different color. Starts at the top, and then from the top it goes middle, down, middle, top. middle, down, middle, top. All right, so our process, once again, if you wanted to connect these, you certainly can, but that's not the point of this because that would be cosine, and our actual question is cotangent. But what we just talked about is where the denominator, which is cosine, is 0, which happens here, 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 and here. There's actually going to be a vertical asymptote for tangent because that's going to create a denominator of 0. So I'm now going to mark these as my vertical asymptote. So this is a vertical asymptote. Highlighters are really helpful here because you can really see the colors with the vertical asymptotes. These are really probably the most important part of the graph, vertical asymptote. Okay, and then since this is tangent, tangent has that upward shape. It's not reflected, so it's going to stay that way. And exactly in the middle of the vertical asymptotes, so at 720 is this first exact middle, you're going to hit the middle of your graph, which is always your sinusoidal axis. So my graph will look like this. This green is tangent theta, which is the actual question that I'm being asked. And that is tangent theta. A lot of people ask about these dots that were for cosine. We don't really use them at all. It's just that, you know, cosine helped us, so they're there, but they don't necessarily pertain to tangent. Okay, so if we talk about the period of this green function from 360 to 1080, that represents one cycle, because if you go beyond 1080, you're going to start to repeat yourself. Think of a cycle as if you cut out this piece of your graph and you moved it, you slid it over, then it would be right on top of itself. That's what a cycle is the part before it starts to repeat itself. So from 360 to 1080, if you subtract those two numbers, you get 720. And what you should notice is that this is and always will be exactly half of 1440, the period you found from your trig. Okay, and that's because, I mean, if you think about what tangent is, it's actually kind of putting two trigs in one function. So it kind of makes sense that these guys are going to be double the amount as this one. Okay? All right, let's go on to another example. All right, so I'm just going to do this bottom example, number 3, because I just kind of want to skip ahead. And so our process is going to be for cotangent theta, we're going to do, we know it's cosine over sine. So what that tells us is that if we graph sine, so the trig I'm going to use is sine, then since that's in the denominator, I'll put the vertical asymptotes there. So just kind of pretend like this equation has a sine here instead, and do everything like normal. So I know I go up 3, my horizontal shift is right, pi over 2. I do not reflect. Therefore, I will start for sine. So we're still doing sine. I start with the S shape that starts in the middle. My amplitude is 7. My period is going to be affected by this 2 right here. So that's 2 pi over 2, which is pi. And therefore, those critical points are pi over 4 apart. So if I move right, pi over 2 and up 3, so 1, 2, 3, 4, 1, 2, 3, 4. And I'm going to add pi over 4, which does create a little bit of a problem, but if you adjust this with a common denominator, so let's just say this is 2 pi over 4, then you'll fix that problem. So add pi over 4, you get 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4, 9 pi over 4, and 10 pi over 4. If I move vertically up 3, that's my new sinusoidal axis. And from that, I'll go 7 up, which lands me at 10. 7 down lands me at -4. And from there, sine starts in the middle, and then from the middle it goes up, middle, down, middle, up, middle, down, middle. Once again, if you want to connect these, you can. That's fine, but just somehow note, I do a dotted line when I plot them, but it's not your actual question. This is the point or the part where you say, okay, my actual question is cotangent. So I graphed sine to find those vertical asymptotes that are going to lie on the zeros. Well, the zeros now are at 3 because you've taken that 0 and shifted it up 3. So this is your 0 line. So here at 2 pi over 4, this is our first vertical asymptote. This is a next vertical asymptote, vertical asymptote, vertical asymptote, vertical asymptote. And then exactly in between those vertical asymptotes, so at 3 pi over 4, I'm going to land on the sinusoidal. And cotangent, that's the decreasing one. So I'm going to start up and decrease down. Okay. All right, and that's it.